Hi guys, so today's lesson is on solving radical equations and inequalities. So we'll start with some basic guidelines here. Solving a radical equation. First thing you want to do is isolate the radical on one side of the equal sign. Once you've isolated it, you're going to raise both sides of the equation to whatever power you need to undo the radical. Right, so if you are trying to undo a square root, you'll square. If you're trying to undo a cube root, you cube, and so forth. And then the third step is to solve the variable using all the methods you have already learned. And then with that, once you have a solution, make sure that you check it because not all solutions will work. Some will be extraneous. Okay, so let's run through the very first example here. I've got the square root of x plus 1, and then I have plus 2 on the outside is equal to 4. So as we said, first thing you want to do is isolate the absolute value. So I'm going to subtract the 2 from both sides. So minus 2, and that's going to leave me with the x plus 1 equal to 2. And again, since it's a square root, I want to undo it. So that means I am going to square both sides. Square that and square that. And that gets rid of the radical. So now I have x plus 1 is equal to 4. And then I just have to subtract the 1 from both sides. So x is equal to 3. And we'll just do a quick check to make sure that this all works. So we do the square root of 3 plus 1 plus 2, and we're checking to see, does that equal 4? So we have square root of 4 is 2. 2 plus 2 is equal to 4. This does work, and so that is our solution, x equals 3. All right, so our second example here is a cube root. We've got the cube root of 2x minus 5 minus 2 is equal to 3. So it's the same thing. We want to isolate the radical first. So I'm going to add 2 to both sides, and that will leave me with the cube root of 2x minus 5 on the left equal to, I'm adding 2 again. So I have 3 plus 2 is 5 on the right. And we have an index of 3. So I'm going to raise both sides to the third power. All right, so that undoes that radical, and we're left with 2x minus 5 is equal to 125. Add the 5 to both sides. That gives me 2x is equal to 130. Divide both sides by 2. Gives me x is equal to 65. And again, I'm going to do a quick check to make sure that we did this correctly. Square root of 65 times 2 minus 5, minus 2 on the outside, and we're checking to see, does that indeed equal 3? So we have 130 minus 5 is 125. Cube root of 125 is 5. 5 minus 2 does indeed equal 3. It checks out. And so our solution is x equals 65. Okay, so in our third example, what's changing here, you'll see, is there is an x in the radical, but also an x on the outside of the radical. So again, first thing is to isolate the radical. And it just means I'm going to have a variable on both sides. So adding the x to both sides, I get 2x plus 1 equals x minus 1. All right, so again, I've got to get this x out of this radical. So I'm going to undo the whole thing by squaring it. And I have to square the other side as well. And here's the big difference between the examples we did earlier and now. Now I have a binomial on the right-hand side that I have to square. Okay, so the left-hand side, we have undone the radical. We have 2x plus 1 here equals And then if you remember the pattern, this is going to make squaring your binomial a lot faster than foiling everything out. That first term squared, x squared, and then 2 times the first term times the second term, so that's minus 2x, and then negative 1 squared is plus 1. So adding 1. Okay, so at this point, we'll notice that I do have an x squared term and an x to the first term, and then also a constant. So I'm going to collect everything to one side and set it equal to 0. And you guys know I always like to keep my lead term positive, so I'm going to leave my x squared over here. Subtract the 2x from both sides. So I have the negative 2x minus 2x, so that'll be minus 4x over here. And then when I subtract the 1, that's going to go away, and all of this is equal to 0. Oh, I just realized I forgot my square there. Okay, so now I have x squared minus 4x is equal to 0. So I'm going to factor out my x here. I'm left with an x minus 4 equals 0. So I have 2 solutions right now, x equals 0 and x equals 4. So again, I do want to check, especially right now, because with 2 solutions, often the second one is extraneous. So if I plug in the 0, I'm going to get the square root of 0 plus 1 minus 0 is equal to negative 1. Okay, and again, that's what we're trying to ask ourselves. I have 1 here. 1 minus 0 is 1. And does 1 equal negative 1? It does not. This is a false statement, which means x equals 0 is not a solution. Okay, so checking the x equals 4 now. Let me see. Let me try to make a little bit more room here. Okay, so x equals 4. I'm going to have the square root of 4 times 2 is 8 plus 1 minus 4. And we're checking to see, does that equal negative 1? So we get 9. Square root of 9 is 3. 3 minus 4, does that equal negative 1? It does. This one checks out. So we have one solution, and that solution is x equals 4. Okay, so adding another layer in part D. Okay. So now I've got radicals on both sides, but I also have this additional term that's being added in. So what's going to happen here is we kind of have to go through the process a couple times. I do have my radical on the left already isolated, and so I'm going to start with this one. I'm going to square that. And then I'm going to come to the right, and I'm going to square that entire side as well. So on the left side, that's going to undo the radical, and I get 3x plus 2. And on the other side, keep in mind that this is now a binomial, and so it's like foiling or using the pattern, special pattern for binomial squared. So 1 squared is 1 plus 2 times 1 times the square root of 2x minus 5 is 2 times the square root of 2x minus 5, plus, if I take the square root of 2x minus 5 and square it, I'm going to end up with just 2x minus 5. All right, so I still have a radical, and so we're going to go through the process all over again. I'm going to isolate that radical on one side. So subtracting my 2x from both sides, I'm left with an x on the left, and then on the right I have 1 minus 5, that's negative 4, and if I add that 4 to both sides, I end up with 6 over here is equal to 2 times the square root of 2x minus 5. Okay, so now I've got this term right in the front. I would check to see if I can divide that to make things easier, but x plus 6 is not evenly divisible by 2, so therefore I'm going to leave it where it is. And just like we did earlier, I still need to undo this radical, so I'm going to square that side, and again, square the other side. All right, so binomial square on the left side again. I have x squared plus 12x plus 36 is equal to, and I'm squaring all of this, so that means I have to square the 2 and the square root of 2x minus 5. So 2 squared is 4, and the square root of 2x minus 5 squared gives me 2x minus 5. All right, so at this point, I'm going to distribute the terms on the right side, collect everything on one side to make it a quadratic. Okay, so the left side right now doesn't change. And on the right side, I have 8x minus 20. All right, so collecting everything, subtracting that 8x from both sides, I get 8x plus 4x. And then adding the 20 to both sides, I get plus 56 is equal to 0. All right, so again, I have a quadratic here, and I'm looking to see, is this quadratic factorable? And it is not, so therefore I'm going to try the quadratic formula. So I get x equals negative b, so that's negative 4, plus or minus the square root of b squared, so that's 4 squared is 16, minus 4 times a is 1, times c is 56. All over 2 times 1, which is 2. And then I'm looking at that discriminant, and I'm seeing that I have a negative discriminant. All right. So the discriminant is negative. And as we recall, a negative discriminant means that we have two imaginary solutions. So we're not going to continue with this. We're just going to say no real solutions. Okay, and I know that was kind of a lot of work just to come down to no real solutions. All right. So moving on to our next example, you'll see this one is in exponent form, not radical form. The process, I actually kind of like doing these more, because if we look at this, again, we're trying to isolate x by itself. So I'm going to peel away everything that's not attached. So first thing I'm going to do is divide both sides by 3. And that's going to give me x to the 3/5 is equal to 8. Now, keep in mind, we are trying to get x by itself, which is essentially x to the first power. So right now, x is being raised to 3/5. I want it to be x to the first, which means if I raise both sides to the reciprocal of this power, I end up with, on the left, the 3's divide out to 1, the 5's divide out to 1, and that gives me that x to the first power that I was after. And now I have basically the cube root of x to the 5th. So I'll write it out as the radical, not x to the 5th, sorry, 8 to the 5th. All right, and again, easier to go smaller first. The cube root of 8 is 2, so this is 2 to the 5th. So x is equal to 32. And again, we can do a quick check here. 3 times 32 to the 3/5, and does that equal 24? And again, the 5th root of 5 is 2. 2 cubed is 8. We get 3 times 8, and does that equal 24? Yes, it does, and so our solution was correct. X is equal to 32. Okay. All right, so this is the last one I'm going to work with you until we get to the inequalities, and then I've got several for you to try. So, same thing, we're in the exponent form, and I've got this entire binomial being raised to the 1/4. And so again, I want it raised to the first power. So to undo it, I'm going to, again, raise all of it to the reciprocal of 1/4, which is 4. And if I do it to one side, I have to do it to the other as well. Okay, so now on the left, I have 5x squared minus 4 is equal to x to the 4th. So now I want to collect everything to one side, set it equal to 0. Again, I want to keep my lead term positive, so that's the x to the 4th term. So I'm going to move the other terms over. So x to the 4th minus 5x squared plus 4, all of that's equal to 0. And then I want to see if I can factor. And this is easily factorable into x squared and x squared. All right, so we get x squared minus 4 and x squared minus 1 equal to 0. And then if you'll notice, we have the difference of two squares and we have it twice, which means this one factors into x plus 2, x minus 2, and this one into x plus 1 and x minus 1. So we now have 4 different zeros here, so I'll write them all out. So we have -2, -1, 1, and 2. And like we did earlier, I want to go ahead and check. So checking, if I start with -2, I get 5 times -2 squared minus 4 is equal to -2. Oh, and I'm sorry, I forgot to put my 4th power on here. So I'm looking at this right away, and the fact that I have, oh, I just realized I didn't put the 1 up there. I'm supposed to be taking the 4th root, which is an even root of this binomial here, and have it equal a negative value, which does not work. So that means that -2 cannot be a solution. And then, obviously, if -2 can't be a solution, -1 cannot be a solution either. All right, so the only thing I have left to check is 1 and 2. Let me put a line there. So I have 1 squared is 1, so 5 times 1 is 5 minus 4. All of it to the 1/4 power is equal to 1. 5 minus 4 is 1. 4th root of 1 is 1. Again, that's what we were checking. And yes, 1 works. And now I'll try 2. I have 2 squared is 4 times 5 is 20. 20 minus 4 is 16 raised to the 1/4. And does that equal 2? The 4th root of 16 is indeed 2, so this one checks. And so we do have 2 solutions for this one, +1 and +2. Okay, so at this point, I would like you to look at these next 4 problems here and try them on your own. Actually, there's 5 problems. There's one more down here. So we'll start with these 2 here. So go ahead and pause, work through them, and then you can come back and compare your solutions to my solutions. Okay, so here are the solutions for A and B. So for A, we have x equals 14, and for B, we have x equals 11. Okay, here are the solutions for C and D. So C, as you can see, we ended up with 2 solutions that worked, x equals 0 and x equals 4. And then in D, just x equals 2. Okay, and here is E. We have one solution, x is equal to 81. All right, I hope those went well for you. The next part we are going to look at are radical inequalities. All right, so solving these is very similar to the equations. There's only one other thing. We have to also take into consideration the domain of the radical. Okay, so in A, I've got square root of x minus 3 less than or equal to 5. So just like we did with the radical equations, I've got to undo this radical. So I'm going to square both sides. That leaves me with x minus 3 is less than or equal to 5 squared is 25. Adding the 3 to both sides, I get x is less than or equal to 28. Okay. So the other thing I have to take into consideration is looking at the radical, I see that the radicand x minus 3 has to be greater than or equal to 0. So remember we talked about this last class. The domain of even roots, the radicand has to be greater than or equal to 0. So in this case, when I solve for x, I end up with x is greater than or equal to 3. Okay? So my solution says that x has to be at least 3, but less than 28. So I'm going to put that into interval notation from 3 to 28 inclusive. So there's my solution. All right. So for B, I've got 3 times the square root of x is greater than or equal to 9. So just like before, let's isolate that radical first by dividing both sides by 3. So that gives me the square root of x is greater than or equal to 3. Now I have to undo the radical, so I'll square both sides, and that gives me x is greater than or equal to 9. Right. So again, taking into consideration the radicand, all I have is an x, so I know x is greater than or equal to 0. Well, 9 is already greater than or equal to 0, so I don't have to worry about the other end. So our final answer is x is greater than or equal to 9, or if we put that into interval notation, 9 to infinity. All right. So for our next one, it's a cube root. I have a cube root of x minus 8 is less than or equal to 3. So just like we did before, I'm going to cube both sides to undo that radical. That leaves me with x minus 8 on the left, less than or equal to 3 cubed is 27. Add the 8 to both sides, I get x is less than or equal to 35. Now in this case, it is a cube root. It's odd, so we don't have any domain restrictions because it can be positive or negative. So therefore, we are perfectly fine with our answer of x is less than or equal to 35. Or we can put that into interval notation from negative infinity up to 35 included. Okay. So those are a few examples of the radical inequalities. I now have 3 for you guys to try, and that'll be the end of the lesson. So again, go ahead and pause and try to work through the next 3 here, and then come back and check your solutions. Okay, so here's the first 2 you tries. We see over here we end up finding that x is less than or equal to 4 over 3. And then when I go back and check the domains for both of these, in the first one, we do x plus 4 is greater than or equal to 0, which means x has to be greater than or equal to negative 4. Okay. And then we look at this one here, x has to be greater than or equal to 0. Well, this is the lesser of them. And so, because again, if we tried to plug into the original, even if I tried, say, -1 into here, it would work, but a -1 into the right-hand side would not. It would be undefined. So I have to use 0 as my starting point. So from 0 to 4/3. Okay, and then in part B, we find that x is greater than 5, and again, I just double check my domain. X minus 1 is greater than or equal to 0, so x has to be at least 1, and so as long as we're greater than 5, we will satisfy the condition of being x greater than or equal to 1, and so the solution to that one is 5 to infinity. Okay, so here is the final u-try. In isolating x, we find that x is less than or equal to -27. And because this is a cube root, it's odd, there are no domain restrictions to take into account. So our final solution is just -infinity to -27. Okay, so from here, you should be able to complete your homework. You can have the rest of the period to work on that, work on your problem sets, and then, again, if you have any questions, just email me. Thanks.